Alright, this section of notes combines 4.5 and 4.6. 4.5, these are congruence theorems for just right triangles. And a lot of these are going to look familiar because we've done something similar. These are just special names for right triangles. So this first one is the Leg Leg Congruence Theorem. So obviously all of these triangles are going to have a 90-degree angle marked, okay? So that's already a given here. And if this was any other triangle, not a right triangle specifically, you might think, oh, this is side, angle, side, side, angle, side. And yes, technically we would accept that answer as well. But specifically, right triangles also get these special names. And in this case, it's the Leg Leg Congruence Theorem. Because we have two legs, this one and this one, that are specifically marked to be congruent to the other triangle. So leg-leg congruence can also be seen as side angle side. Then we have the hypotenuse angle congruence theorem. And like the other theorems, whatever is labeled, that's what you're going to go with. So in this case, I have a hypotenuse and an angle marked. Again, obviously the right angle is there, so that's already a given. I don't have to label that one. This one, you may think of it as the angle side congruence theorem, but like I said, because it's a special case, we have a right triangle, then it's going to be called the hypotenuse angle theorem. Then we have the leg angle congruence theorem. So again, we have a leg and an angle that's not the right angle, sorry. And so this, if I were just looking at any other one, it would be angle side angle. But because it's a special right triangle, we can call it the leg angle congruence theorem. And the last one you actually already saw in a previous section, the hypotenuse leg. Here I have the hypotenuse across from that 90-degree angle. That's how I know it's the hypotenuse. And then another leg being labeled as congruent. Okay. So for these four pictures, I want to determine which postulate or theorem applies to the pictures that are given to me. And then if I were to go back and think about chapter 3 of rigid motions, how would I get these to map themselves onto each other? Okay. So here, I'm going to zoom out so you can see most of these. For the first one, I have the shared hypotenuse. Okay, I have the shared hypotenuse, which means that these are probably going to be congruent. They have the same measurement because they share that same size hypotenuse. And then I have an angle. Okay, so I have a hypotenuse angle. So it's this one, the hypotenuse angle theorem. For number 2, I have a leg and another leg. Leg and another leg, which would be the leg congruence theorem. Number 3 does not have enough information. I can't just assume this is a right triangle. So I'm just going to write none. We never want to assume in geometry, so I'm going to write none here. And then the last one has an angle and a leg. Angle and a leg, okay? Or leg angle. And you can write those out if you want. You can go leg, leg angle, and then hypotenuse angle. Remember, these could technically also be the ones we've learned in past sections. So this side angle side would work. That one's still not going to work. This one would be, oh, sorry, I was trying to label number 2. This one would be side angle side. This one would be angle side angle because we have the side between our two angles that are marked. And this last one would be, we can go angle side. Okay. But again, they have a special name when we are talking about right triangles specifically. So let's go to the next page. That's all with the right triangles. So it's just taking the names that we already know, but giving them a new name because right triangles are special. Okay, so on a test, we would take either the angle side or the hypotenuse angle. And if it's multiple choice, we wouldn't give you both. For 4.6, talking about isosceles triangles. So isosceles triangles, remember, have two congruent sides. Here they are. And if we have two sides that are congruent, then their opposite angles are also going to be congruent to each other. That's what the isosceles triangle theorem tells us. The opposite of that, if I have two congruent angles here, then their opposite sides will also be congruent. So this is information that you can guess by being given either congruent sides or given congruent angles, is that their corresponding sides or angles will also be congruent. So here we are, this picture, if AC, so I need to label things here. Let me go with the highlighter. AC is congruent to AD, okay? Name two congruent angles. So if I'm saying this side and this side are congruent, what would be two congruent angles? Well, I'm hoping you're thinking that the opposite angles will also be congruent, those base angles, okay? So how would I name this first angle over here? I can say that's angle ACD. You can switch the letters there if you want to start with D and then go to C and then A. And then this angle here, I'm going to call that one ADC. Okay, so those two angles would be congruent because they are across my two congruent sides. Okay, next problem, I'm going to erase here. It says if CED, so CED is here, this angle, is congruent to CDE, this one right here, name two congruent segments. So this one's the opposite. If the two angles are congruent, then their opposite sides are congruent. So here I would say that CE is congruent to CD. And you may for these also see just the congruent symbol if this was like a multiple choice question on a test. But pretty much it's saying, again, opposite sides or angles of corresponding congruent angles or sides are going to also be congruent. Okay. Number 5, find the measure of ABC. So ABC is here. Okay, so if this is 60, this is 60, and this is across from a side that's marked as congruent, then this, because it's across from a side that's marked as congruent, should also be 60 degrees. Okay, so go with the information you know for this picture. Again, let me clear it and do that one more time. These angles are congruent. So then, or the sides are congruent, so then their opposite angles will also be congruent. That's how I know that the angle is 60. For number 6, it's a little bit different. So I have the sides marked, and I know their opposite angles are going to be congruent. Okay, and this one's already 40. So I'm looking for EDF. So EDF is this one right here. Well, I know that all triangles add up to 180 degrees. So 40 of those degrees are already accounted for. That leaves me with 140 degrees to work with. Okay? Because these two angles are split into two equal angles, I'm going to take that number and divide by 2, which means that each of these is going to be 70 degrees. And that's how I get my answer. Number 7, I'm going to start using some algebra here. Find the value of each variable. So for number 7, I have a triangle, and these two angles are congruent, which again, it means the opposite sides are congruent to each other. So I'm going to set up an equation here where 2x plus 4 is equal to 3x minus 10. And my goal here is to find the value of the variable, so I have to move things around. I'm going to move the 2x over here. That gives me 4 equals 1x minus 10. And then I'm going to add 10 to both sides. So I get x equals 14. And that's my answer. Number 8 is very similar, but this time I'm given the actual angle value. So these sides are congruent to each other, therefore their opposite angles are congruent to each other. Now, I'm not given an angle measurement here, but I'm given enough information to figure it out. So this angle I know is 90. I know that all triangles add up to 180 degrees, so I'm going to do my math here. And I know I have 90 degrees left to work with between these two. Because these are going to be congruent angles, I know that each angle then gets to have 45 degrees equally. So the equation that I'm going to set up here is just a little bit different. I'm going to set 2x plus 3 equal to 45. So I subtract 3 from both sides. 2x equals 42. And then I divide 2 on both sides. And I get x equals 21. Okay, moving on to the next page here. I have two more corollaries, so kind of like theorems here. If I have A, B, and C be congruent to each other, then I can assume that the three sides are going to be congruent to each other. So if I have an equilateral triangle, we talked about this one in 4.1. Equilateral means 3 equal sides. So if I have 3 equal sides, then that means I also have 3 equal angles. So an equilateral triangle will also be called an equiangular triangle, okay? Same thing if I go backwards. If I have an equilateral triangle, then I'm going to have 60-degree angles here because I'm going to split the 180 degrees that every triangle has into 3 equal angles. Okay, so let's put this into practice. So here I have two sides that are congruent to each other, okay? And so at first I'm like, okay, well, they are 5 and 5, which means the opposite angles are going to be congruent, okay? This is already taken, so I already have 108 degrees minus the 60 that's already taken. That gives me 120. When I divide that into 2, that means each of my angles is 60 and 60. So if all angles are congruent, that transitions into all sides being congruent. So PR also comes out to 5 centimeters because all angles are 60 degrees in this case. Okay, number 2, find angle T. Well, okay, I know that if this is 60, then I have 120 degrees to work with between the other two angles. 3.5 is across my 60, so 3.5 is across angle T, so because that's 60, angle T is also going to be 60 degrees. For example 3, find the value of each variable. So I'm going to go ahead and start with y. So y is labeling this side over here, and these marks show me that all three sides are going to be congruent to each other. So if this side equals 2y minus 6 and this side equals 8, I can set up my equation as 2y minus 6 equals 8, and then start solving for that variable. So I get 2y equals 14, divide both sides by 2, so y comes out to be 7. And then to find x, well, if I have 3 equal sides, then that means I have 3 equal angles. So then my angles, which are labeled the same thing, 3x, are each going to equal 60 degrees total. So then I just divide by 3, and x comes out to be 20. Okay, last example here. Find the value of each variable again. So in this case, I have 3 equal angles. And again, when all my angles are the same, that means they're each 60 degrees. So to solve for y this time, I'm going to set 5y equal to 60. I'm going to divide both sides by 5 and get y equals 12 here. And then for my sides, if I have 3 equal angles, I also have 3 equal sides. So in this case, I can set my sides equal to each other and then solve for x. Okay, so I'm going to subtract 3x from both sides. That gives me 2x minus 6 equals 2. I can add 6 to both sides. 2x comes out to be 8. And then I can divide by 2. And x equals 4. And that's the end of this section.